Hello, college math topics. This is lesson 4.4. This is the last lesson in our inequalities unit, and we're going to look at systems of inequalities. So the objective for today is to be able to write systems of inequalities to model scenarios and to use graphs to find possible solutions to systems. This will be a review of what we've done before, but instead of graphing one inequality to model a situation, we'll have more constraints and have more graphs to look at. So, systems of equalities. The solution to a linear system of inequalities is represented by the shaded region on a graph. The solution to a system of inequalities is represented where the shaded regions overlap. So down here we see a system of inequalities right here. We have 2x plus 5y is less than 10, and that is this blue dashed line and everything shaded below it. Anything in that region is a solution to the first inequality. The second inequality, x minus 3y is less than or equal to 1, is made by this solid line inequality, and everything shaded above that line is a solution. So if I want a solution to the system, I need a solution that works for both inequalities. So any value that is in the overlapping region is going to be a solution. So this is where all our solutions are. Everything on this line and just below the dashed line. Because remember, if you're on the dashed line, you're not a solution. So what's a possible solution? Let's see right here. Negative 2, comma 1 would be a solution to that inequality system. Right here is going to be a solution. 0, 1. And right there we have a solution, 1, comma 1. And there's many, many more. Okay, so now we're going to read a situation, see if we can model it with inequalities, graph the system, and then be able to find out potential solutions. So this first example, Linda works at a pharmacy for $15 an hour. She also babysits for $10 an hour. She needs to earn at least $220 this week, but does not want to work more than 20 total hours. Write and graph a system of inequalities to find a possible number of hours she can work at each job. So there's a couple constraints here. One is that she wants to make at least $220 per week. So we know she makes $15 an hour at the pharmacy and $10 an hour babysitting. So how many hours she's working is the variable here. So I'm going to let x represent the hours at the pharmacy. And y will represent the hours babysitting. Okay. So in this case, if she wants to make at least $220, we know that she makes $15 an hour working at the pharmacy, and she's going to work for X hours, some unknown value. So that's how much she makes just at the pharmacy. She makes $10 an hour as a babysitter, and she works Y hours babysitting. So $10 an hour times however many hours babysitting tells us how much she's going to make babysitting. The 15x tells us how much she's making at the pharmacy. If I add that together, that's her total profit. And we know it needs to be at least 220. So that value has to be either equal to 220 or more. So we're going to use a greater than or equal to 220. So that represents the first constraint. The second constraint is that she wants to work more than 20 hours. Actually, does not want to work more than 20 hours. So she wants to work under 20 hours. So if she works X hours at the pharmacy and Y hours babysitting, if we add those up, that value needs to be under no more than 20 hours. So it could be 20 hours, or it could be equal to it, or less. So there's our system, and our goal is to now graph it and come up with a possible solution to the situation here. So $15 an hour at the pharmacy, $10 an hour babysitting, and we want this to be greater than or equal to 220. And we know that if I take the hours at the pharmacy plus the hours babysitting, we want that to be no more than, so less than or equal to 20. So anywhere in the solution set, in both in the overlapping shaded region is going to be a solution. So I'm going to snag a quick pic of this and put it in OneNote. Okay. So if I want to find a solution to the inequality, it's going to be anywhere in the overlapping shaded region. So if I find a point, let's say right here looks like a point, that's a solution because we have solid lines. And maybe right here we have a solution. So find a possible number of hours she could work at each job. Well, one of them is right. Let's look at this one right here. This is the point 10 comma 5, 6, 7, 8. So 10 comma 8 is a solution, and the 10 is the hours at the pharmacy, and the 8 is the hours babysitting. So there's a combination that will be under 20 hours but make more than $220. Right here we have another solution, 416. And there's many solutions, right? Any point in this region would be a solution. Again, only using positive numbers here because we can't work a negative amount of hours. The next part of the question is, what is the maximum number of hours she can, she can work babysitting in this situation? And in this case, if babysitting is the y value, the most that she can possibly work while still making $220 is this top point right here, which is at 16. Anything above that, she will be working over that 20 hours, and that is not going to be a solution here. So 16 hours. Okay? Simple enough. And you can see that this is similar to things that we've done already. Okay? Next example. A surf shop makes $150 profit on each surfboard and $100 profit on each wakeboard they sell. The owner wants to sell at least 10 surfboards and at least 20 wakeboards each month and have a profit at least $2,000 total. So again, write and graph a system of inequalities and find a possible number of each board they could sell. So the first constraint is that we want to, let's see, the owner wants to sell at least 10 surfboards. So I'm going to let X be the surfboards. And I'll have Y be the wakeboards sold. So the amount of surfboards that are sold has to be at least 10. So the value of X has to be greater than or equal to 10. We need at least 20 wakeboards sold, so the value of wakeboards, Y, has to be equal to or greater than 20. And finally, we want to sell, we want a profit of at least $2,000. So the amount of money we're going to make has to be greater than or equal to $2,000. And we're making $150 on each surfboard. So $150 times X surfboards is how much we're making on surfboards. We're making $100 profit for each wakeboard. So $100 times Y wakeboards is how much I'm making on the wakeboards. If we add them together, that gives me my total profit, which has to be greater than or equal to 2,000. So we're going to graph this and find a solution. So we said that the amount of surfboards has to be at least 10. So it's got to be in that green section. The amount of wakeboards has to be greater than or equal to 20. So it needs to be in this purple section. So anyone in this overlapping section is going to have at least 10 surfboards and at least 20 wakeboards. And finally, I'm making $150 for each surfboard sold, plus I'm making $100 for each wakeboard sold. And that needs to be at least, so again, greater than or equal to the $2,000. So to find a solution here, it's got to be in this black shaded region, purple shaded region, and green shaded region. So really, that's just anywhere in this top right corner. Okay? So that's where all my solutions live. So I'm going to, again, snap it onto the old OneNote here. Oops. Okay. All right, so then we just want to find a possible solution. So let's use this one right here. This would be the point 20, 30. So let's do a different color. So 20, 30 is a possible solution. In other words, 20 surfboards and 30 wakeboards. So that would be over 10 surfboards, over 20 wakeboards, and that would make us more than $2,000 because it's in all of the shaded regions. Okay. And last but not least, we got the question, Tony wants to plant at least 80 acres of corn and at least 50 acres of soybeans, but cannot plant more than 200 acres of crops total. So let's write and graph a system of inequalities to model this possible number of acres he can plant for each crop. So he can plant a certain amount of acres of corn and acres of soybeans. So I'm going to let X represent the acres of corn. Y is the acres of soybeans. And we know we want to have at least 80 acres of corn. So the value of X has to be either equal to 80 or more. We want to have at least 50 acres of soybeans. So the value of Y, which is soybeans, has to be at least 50 or more. So it's going to be greater than or equal to 50. And we know that we cannot plant more than 200 acres of crops total. So if I take the total amount of crops, the corn plus the soybeans, that cannot go over 200. So it's going to be 200 or less. So it's going to be less than or equal to 200. So we're going to graph this, John, and then find a solution to that inequality. In this case, we have to have at least 80 acres of corn, at least 50 acres of soybean, and the total acreage has to be no more than, so less than or equal to, I believe it was 200. So we got to zoom out of this thing. So let's go in order here. So this green region is my solution set to having the right amount of corn. The purple region is having at least 50 acres of soy. So again, we need to be in this purple region, but I have to have no more than 200 acres total. So I have to be under this black line. So really this triangle region is where all my solutions settle. And this is when the modeling systems become a little bit more useful because there's only so many solutions to the system. And now we can kind of quickly and visually see where they all are at. All right. So we're going to copy, paste that in there. And so any solution would be any point in this region. So I don't know, let's use this point right here. That's 100, comma 60. Oh, I don't like that color. So 100 acres of corn, 60 acres of soybean would check out. That's at least 80 acres of corn. 60 is greater than 50, so that's at least 50 acres of soybeans. And if you add them together, that's 160, which is less than our total, or our maximum, which was 200. So that's it. Again, this was the last part of our unit 2, or unit 4, which was inequalities. Next class, we will review for the SAT portion of the test, because we already had the skills portion. So the SAT test will be next class, and then we'll have a performance task the following class. And if you like this video and want to see more content, make sure to smash the like button and ring the bell for notifications. Believe it or not, over 4/3 of my viewers aren't subscribed! Exclamation point. Help me reach my 2025 goal to have a dozen subscribers. This video is brought to you by Surfshark, Raycon, Factor, Shadow Legends.